takes is a spark of curiosity, of interest, of delight, to ignite a flame of passion that burns brightly and sends lives onto a new path. We are the spark. We are the Rebels. Our team started in 2008 at Eastwood Collegiate Institute, making us the longest-running FRC team in Waterloo Region. Like a spark, we started out small and grew. In 2017, the Rebels became a community team, accepting students from all over the region and tripling in size, making FIRST more accessible to all students in our community. With this increase in members, our passion for innovation and discovery grows. Despite our size, we kept the mindset of a small team, encouraging all students to explore every aspect of the FIRST program, providing hands-on training and learning opportunities that change lives forever.
Hey everybody, and welcome to the 2702 Rebels 3rd Design Challenge. I'm Madeline.
I'm Zoe.
I'm Chloe.
I'm Layla.
I'm Jessica.
I'm Ethan.
And I'm Michael.
And we are part of the 2702 Rebels. The 2702 Rebels are a FIRST robotics competition team, and each year we get 6 to 12 weeks to design, build, and program a robot to complete a challenge. Today, we have an elevation challenge for you to work on at home. If you have any questions throughout this video, there's a Google form in the description below where you can submit these questions. We'll be answering all questions at the end of our live stream. Now take it away, Chloe.
Thanks, Madeline. Hi, everyone. I'm Chloe, and this is my 5th season of robotics. Today, I'll be telling you guys what we're going to be doing in this live stream. Today, we're going to talk about the climbers on our Pass for Robots, the rules for our brand new challenge, 3 new scientific principles, how to make your own pneumatic system at home, and, of course, tool safety. This design challenge is the Elevation Challenge. Your goal is to elevate. That's a fancy word for lifting. Different coins up a certain height to earn as many points as possible. Your elevator is going to need to be very strong if you want to pick up a lot of coins. Don't get too worried about how you're going to do this when you have so many ideas, because we will help you to narrow them down and give you some tips on how to take on this challenge. If you need to, check out the design process section of our last video. We will have a Q&A session at the end of our live stream, where you can ask any questions that you thought of throughout the live stream. To ask them, just simply type them in the Google form through the link in our description.
Hi there, my name is Madeline. I'm in grade 11, and I've been involved in FIRST for 7 years. As you may know, FIRST comes out with an FRC challenge every single year at the beginning of the year. At the end of the game, all robots had to climb or elevate themselves in one way or another. Some years there was a platform, and others there was a bar or rope you would grab or hang from. The 2018 Climber Challenge was to grab onto a bar 7 feet up. It was a smaller bar that couldn't fit all 3 robots on the Alliance unless they had a smaller climber mechanism. The climber we built had 2 hooks that went in between the sides of the bars to hang on to them. To make sure another robot could climb on, we had forks that flipped down. Here's how our forks flip down. After the forks extended, another robot could drive onto them. This allowed us to raise both robots up 1 foot. Our 2019 robot had a climber that lifts the robot up a set of stairs. It uses the intake and another subsystem we call the stingers to climb up the stairs. The stingers are small poles that extend out from underneath the robot to lift the robot's back, as the intake raises the front. As we move forward, the wheels will approach the platform. Once the wheels are on the platform, we drove the rest of the way up. Our 2020 climber lifted up our robot after attaching onto a bar that could swing. There is a pneumatic cylinder which pushes the arm up or down for the climber. For many years, our team has used pneumatics on robots. Pneumatics is pressurized air that's used to move pieces. Our 2019 hatch grabber also moved up game pieces using pneumatics to pick up and place game pieces. If you want to learn more about our 2020 or 2019 robot, check out our previous live streams available on our YouTube channel.
Hey all, I'm Layla, and this is my 2nd year with the Rebels.
I know that, of course, you've been looking forward to this part the most, so now I shall present the rules of this challenge.
As you already know, you're going to have to elevate some coins in order to complete this challenge. Sounds simple enough, but in the real world, physics and your contractors will always make your life harder with rules and laws. And this is where I come in.
First, I'll start with a point system for each of the different coins out there. Here's a chart outlining what each of the coins is worth, which you'll also find in the rules document in the description. Loonies and toonies are worth 7 points, quarters and nickels are worth 4, and pennies and dimes are worth 2 points. And no, you can't use foreign currency.
Just a side note, if you really want to be sneaky, you can ask your parents for the coins and then challenge them that you get to keep all the coins you can lift with your device. I mean, you could pocket $10 right there.
Don't tell them this was my idea, though. Second, because the main theme of this livestream is pneumatic systems, we'll give you an extra 70 points if you use such a system in your design. So, unless you have 70 points worth of coins, use a pneumatic system. But don't worry, Jessica will show you how to build these systems in a bit. Third, all your coins have to start within 5 centimeters from the ground, meaning that part of your mechanism can be under the coins at the start.
But if you're just 1 millimeter above 5 centimeters, you're immediately disqualified. Just kidding, but seriously, don't put your coins more than 5 centimeters above the ground. It's just not cool.
Fourth, you have to lift all your coins at least 25 centimeters off the ground. But if you're show off and decide you want to lift them like half a meter instead, be my guest. You won't get any extra points, but judges do like fancy designs. Fifth, once you lift your coins, you're going to have to keep them up there for at least 20 seconds in order for your points to count. Now, however, showing off will be worth it. For each extra second you can keep those coins up there, you'll get 2 extra points, for a maximum of 30 points or 15 seconds. And last but not least, when you're done lifting your coins, you have to bring them back down gently. Don't let them crash down. Imagine riding an elevator that would just freefall every time it went down.
You'd be a pancake. Please treat your coins with care.
Woo, and that's basically it. Please note though that you can only indirectly operate your mechanism.
Meaning that you can't just lift the coins with your hand, or lift the container that's holding the coins. In fact, you shouldn't be doing any lifting at all. I mean, then what's your mechanism for?
You'll find all these rules outlined in the rules document in the description for future reference. Submit your designs to info@2702rebels.com. We'll be answering any of your questions at the end of the live stream.
I hope you're not too overwhelmed yet, since Michael and Jessica are about to bombard you with science and engineering principles. Enjoy the rest of this live stream and the tackling of this challenge. Take it away, Michael.
Thanks, Ayla. And now, let's talk about lifting. And to start off with, hydraulics and pneumatics. Don't worry about these big words. They basically mean to move with water and to move with air. And they both operate under the principles of fluid dynamics, or the movement of fluids. But what is a fluid? Isn't that just water? Well, a fluid is just something that flows, so that includes both liquids and gases. So, if water and air are both fluids, why do they have different names, hydraulics versus pneumatics? Well, to answer that, let's first look at water. The water molecules here have been enlarged so that you can clearly see that they're all packed together pretty tightly. Now, to really see the difference between water and air, we need to try to push both with a stick. Let's zoom into the cup and see what happens. When we apply our force, aka push, down, there are molecules in the way, so we have to push them out of the way. But there's nowhere for them to go in the direction down, so the molecules that we are pushing other molecules to get some space, and they start pushing down and to the side. And then those molecules that are being pushed to the side do the same thing, except this time they're starting to push up. This results in the molecules rising up, because that's the only place that they can go, which means that our pushing force that was originally going down has been redirected to go up. Now, let's look at this empty cup. It's full of air molecules. So let's do the same thing as we did with water. When we zoom in, we can see that the air molecules have a lot of space to move around. So when we push our stick down, any air molecules in the way just get pushed out of the way, and nothing really happens. This key difference between no space and a lot of space matters a lot. So how do people use water to move things? Well, as I said before, when pushed, water has to go somewhere. So the way the hydraulics work is by pushing on a liquid and making it so that the only place the liquid can move is by pushing something else out of the way. This means that when we apply force to one side, it gets transmitted to the other side. The great thing is that it doesn't matter how bendy the pipe is. The force will still get redirected to push whatever's on the other end. But how can hydraulics move something really heavy or extend really far, like a dump truck's offloader? Well, when the force applied travels through the pipe, and the pipe's diameter, or cross-section, gets smaller, the liquid molecules can't get any closer, and the same volume of liquid that travels through the large pipe must also go through the small pipe, which means that whatever's on the end of the small pipe will get pushed further and with a greater force. But to make pistons extend really far, instead of having a stick to push the liquid, in the real world people use a tank and a pump to push the liquid, and they open or close valves to extend or retract a piston. Now that's great and all, but where do people use hydraulics? Well, typically in places where we need to move something really heavy, but speed doesn't matter, like in the arms of an excavator, or the offloader of a dump truck, or in the press of a hydraulic press. Now you might be wondering how we can use pneumatics. Well, pneumatics and hydraulics are kind of similar. However, pneumatics works in a slightly different way, because if you remember, air molecules have a lot of space between them. If we replace the liquid in hydraulics with air, the force won't be transmitted as well, as when pushed, the air molecules just get closer together, a bit warmer, and only very slightly push the other end, which is pretty useless. Instead of doing that, what is most commonly done is to have a tank store the air, like in hydraulics. But instead of having a pump to move the air, there's an air compressor that compresses a bunch of air into the tank. What this means is that the air is already exerting a force, and that all that we have to do to take advantage of that force is to open a valve or two, and the air will rush out and push whatever we want it to push.
Thanks, Michael. Hello, my name is Jessica. This is my 4th year on the team, and I will be teaching you how to make your very own homemade pneumatic system. So let's start by looking at the general recipe for how to make a pneumatic system. Like Michael said, a pneumatic system compresses air to control and move objects. Most pneumatic systems need a constant supply of compressed air, which is provided by the air compressor. An air compressor will suck in air from the atmosphere and store it in a high-pressure tank called the receiver, the second ingredient in your pneumatic system. And then, the compressed air is supplied to the rest of the system through a network of tubes that transport the air to various locations, and valves, which can control the flow of air through a tube. So you may be wondering, Jessica, why are you in a kitchen? I'm in a kitchen because designing an intricate pneumatic system is very much like creating your own recipe. Emphasize on creating. Sure, we've all baked before or seen someone bake, but most of the time they're following an already established recipe. You don't see all the hours and trays of failed attempts that go into making a delicious, perfected cookie recipe. In designing a recipe, bakers will experiment with different measurements of ingredients, the order that they should combine ingredients in, and sometimes they'll even swap out one ingredient for another. They need to figure out how long baked goods will stay fresh, and also how to keep them from going bad. Just like bakers, engineers have to play around with the measurements of their component sizes, such as their length, their width and height, their weights, and their shape. They have to try using different materials with different properties to serve a certain purpose. They have to figure out how the components will be put together or assembled, and they need to know how long their mechanism can last before parts need to be replaced, and also figure out how to keep the mechanism functioning for as long as possible. Still not getting it? Take the example of a cookie. A cookie has 4 basic ingredients: sugar, butter, an egg or 2, and flour. Each of these ingredients has a general role in making a cookie a cookie. The sugar obviously makes a cookie sweet, but it also helps the cookie spread out so it's not a lump, and even gives it a crispy texture. The fat in butter adds flavor to the cookie and makes it soft and chewy. Flour basically holds the whole cookie together, providing structure, and an egg's liquidy nature helps bind the ingredients together. These ingredients are the components of a cookie. By serving their individual roles, they work together to make a cookie delicious. But it's not like they are the only ingredients that can do the job. For example, have you ever thought of putting applesauce in your cookies? It can replace an egg as the liquid binding the cookie together. It might even make it a little bit sweeter. Applesauce cookies are often denser than normal cookies, but that might not be a bad thing, depending on your tastes. It's a different approach to making a cookie, but the end product is still a delicious cookie. So as engineers, we need to realize that there's more than one solution to solving a problem, and that different designs and approaches can serve the same function and meet the same goal in their own unique ways. So let's explore the different options that we have for each of the components in our pneumatic system. We'll look at the advantages and disadvantages of each, and then pick the one that best suits our purposes. So, starting off with an air compressor, you're going to need something that can suck in air from the atmosphere. The simplest solution would be just to use your own lungs as the air supplier. When you breathe in, you're sucking in air into your lungs, and it'll stay there until you exhale or pass out. Another less tiring solution would be to use a bicycle pump, if you have one, which can pump more air with less of the huffing and puffing. Ooh, you need to get a check-in.
But don't you need to compress the air?
Exactly, but instead of compressing the air while we're intaking the air, we're going to compress it once it's inside of the receiver. For example, what if we used a balloon as a receiver? We can blow up the balloon to a certain size using either air compressor idea, and then we can connect it to our pneumatic system. The elasticity of the balloon would try to return the balloon to its original size, which would compress the air, forcing it out of the balloon and into the pneumatic system. If you feel the air is exiting too slowly, you can always compress it yourself. In fact, any plastic bag can serve as a receiver as long as you can squeeze air out of it. Now for the tubing. Anything that is airtight and avoids leaking fits the description of tubing. But of course, the main purpose of tubing is to take compressed air and transfer it to certain locations, while keeping the system airtight, of course. Long plastic straws can be taped together with any kind of tape. Oh, be careful. Oh. And so the bendy parts make the connections more flexible. Rolled tubes of paper can also work as tubing. For valves, you can use clothespins or bulldog clamps, basically anything that you can clip on to stop the airflow, and then take off to let air flow through again. Finally, you must ask yourself, what do you want the air pressure to do? Blow up some more balloons? Roll a ball? Lift some coins? How will you make your design serve those functions? You must consider the circumstances that will allow you to perform those specific functions in your design. So you don't have to restrict yourself to a hard air compressor, receiver, tubing, and valve system. Going back to the cookie example, have you ever considered putting mayonnaise into your cookie? Maybe you're gagging at the thought, but hear me. Mayonnaise is basically oil, which is liquid fat, and egg yolks. So it can work the same way eggs and butter work in a cookie. Essentially, you're taking two different components of the cookie and combining them into one. You can combine some of the functions in a pneumatic system as well. For example, a simple syringe and tubing setup. The syringe simultaneously compresses and stores air inside, and you can control the airflow by pushing or pulling on the plunger. You can also get creative with how the air completes your objective. For example, if you fold tape and roll up a piece of paper so that it resembles those party horn things, you can push an object, like a ball. But these are just some of the ideas that you can do at home. If you come up with your own idea for a homemade pneumatic system, go for it! But just remember to use the engineering design process to be as efficient as possible in designing your idea. Here's a link to some of our previous live streams that go in depth on the design process.
Hi, I'm Jerome, and welcome to the Rebels Report. Thank you for joining us today. We will be talking about how many people aren't aware of how to use proper tool safety. And with that in mind, we will also be here to teach you the do's and don'ts of using tools. Breaking news, a child has burned themselves with a hot glue gun.
I was trying to fix these broken forks with a glue gun, and I glued it a bit lopsided. So I tried to fix it while the glue gun was still hot, but now I have a lot of broken forks stuck to my hand.
Ouch, that looks like it hurt. Let's go to Madeline at the scene to give us some tips on hot glue gun safety.
Thanks, Jerome. Hi there, I'm Madeline, and today I'm at Purple Pony Street with some tips and tricks on how to use a hot glue gun. First, don't touch the metal tip on the hot glue gun. It's very hot. Second, don't touch the melted glue. It's hot and no fun to get on your skin. Third, keep your fingers away from whatever you're gluing. If you need to hold the pieces together, ask a parent for help. You can also use pliers, clothespins, or clamps. If you are not comfortable using hot glue guns, there are some also safe and easy alternatives, like tape or white glue, glue sticks, or even sticky tack. Well, thank you for joining me, and now I'm going to send it back to the newsroom for Jerome.
Wow, that was super helpful, Madeline. Now let's take a quick word from our sponsors.
Are you looking for a challenge? Are you interested in learning more about STEM? Well, then you should check out the Rebels Launcher Design Challenge live stream. It has a 100% success rate. Look at the sky from before and after watching. Experts recommend it, and it's free, and everybody can afford free.
Welcome back. Next up, we are going to show you some tool safety. Let's talk to our expert in the field, Zoe, to tell us how to be safe with common household items.
Now, there are a couple of things that went wrong in this video, but let's start with some of the basics. Make sure your fingers are out of the way when you're starting to cut, and don't cut quickly. Take your time. Only cut materials you know that your scissors can handle. For example, don't try and cut metal with a pair of plastic scissors. While you're transporting your scissors, make sure you're always walking and holding the scissors by the blade, which is facing downwards. And as with any tool, ask your parents first if you can use them.
Thank you, Zoe. Next up, we have Layla on the scene with a young inventor who will be sharing some traumatic events that she has experienced recently while working on a project of hers. Let's take a look.
Thanks, Jerome. Today I'm here with Dana Abernathy, who has been a thinker, creator, and innovator for 4 years. She loved creating things that would make the world a better place, until one day, everything went wrong. Hi Dana, how are you doing today? Well, I'm much better now, thank you. Of course, and would you like to tell our viewers at home what happened? For sure. All started just like any other project. I mean, I had almost finished the entire design process and was just doing my final build. I was aiming to cut a piece of paper, and then I heard a strange noise. I looked at the table, and I had cut out a large chunk of hair. I tried to stay calm as I looked over the table, but when I saw how much hair it was, I immediately turned away. The only problem was that I had got my hoodie string stuck onto the hot glue gun when I leaned over the table, so the hot glue gun went flying and landed on my foot, leaving a very uncomfortable burn. Wow, that must have been really hard for you. Thank you so much for sharing. Of course. Thank you so much for your time. Have a nice day. You too. Bye. Now we have an announcement from the Implement Safety Organization on how to help prevent situations like these.
This message is brought to you by the Implement Safety Organization. Using tools is a privilege. Always use all the necessary safety precautions set by parents and professionals. Although every tool is different, and so are the rules to using them, there are several basic rules to follow at all times. Tuck in all hoodie strings or dangling clothing. Take off any jewelry, tie shoelaces and tuck them into your shoes, and put up long hair. Using these precautions can reduce the risk of injury or damage and help save you a lot of trouble.
Well, this concludes the Rebels Report. Thank you for joining us today. Again, I'm Jerome, and we will talk to you next time.
Thank you to everyone who helped put together a tool safety newscast. Hi, I'm Chloe, and I'm back to summarize today's live stream. The 2702 Rebels Elevation Challenge will get you to think about how to move simple everyday objects like coins in new and innovative ways. The goal of today's challenge is to make a mechanism that can lift up as many coins as possible 25 centimeters into the air. The more coins you pick up, the more points you can score. For all the rules, check out our PDF in the description. Just like the other challenges we have done, you can use materials that you find in your house, like straws, cardboard, or fun-colored paper to build your mechanism. This is just a short list because you can use anything you want as long as it isn't a material that can easily start a fire, a radioactive substance, or an explosive device. When you have finished either the Launcher Challenge or the Elevation Challenge, make sure to send a video of it to our email. Remember that you can also submit a design for a previous design challenge, and we still have awesome prizes up for grabs. You can find it on our YouTube channel by clicking the link in our description. When you have finished either of the challenges, make sure to send a video of it to our email.
Hey everybody, and welcome to our Q&A section. So here we're going to be answering questions that you've sent to us so far throughout the live stream. So our first question is, what is the best part of being on an FRC team? Zoe, could you answer this one?
Sure. Probably one of the best parts for me of being on an FRC team is getting to meet a whole new set of amazing, wonderful people and all the opportunities to try new things, like everything from using power tools to writing essays and programming. And those things can sometimes even help you in your future career, which is pretty cool.
Well, thank you. Our next question is, why does air get hotter when you compress it? Michael, could you take this one away?
Yes, thank you, Ethan. When air compresses, the air molecules just get closer together. And since they're closer together, they start bouncing off each other a lot more. And because they're bouncing off each other and moving a lot more, this means the molecules have more energy. And because the air molecules have more energy, that means that they're getting warmer. And that is why air gets hotter when you compress it.
All right, thank you. Our next question is, how can I join a team? I'm only in grade 5. Jessica, could you answer this one?
Sure. So the first organization has different levels of teams for different age groups. FRC is for the high school level of students to participate in, but we also have FLL, which stands for First Lego League, and that's for ages 9 to 14, so probably your age range. It's similar to FRC, but we build robots and code robots using Lego Mindstorm robotics instead. Those are basically where you have little Lego pieces and you can put them together to basically form your robot. There's even a presentation aspect to it where you have to design an engineering solution to a real world problem. So if you want to join an FLL team, you can go to the first website, put in your address, and it will find local FLL teams near you. You can also email us at our email, info@2702rebels.com. It's in the description. And we can connect you to some of the local FLL teams in the Kitchener-Waterloo region as well.
Thank you, Jessica. Our next question is, sorry, excuse me. Our next question is, are you guys proud of your accomplishments as rebels? If so, what are your accomplishments? Madeline, could you answer this one?
Yeah, so we've accomplished many things as a team that we are very proud of. Some things include winning the Creativity Award for the first few years in a row and making it to the World Championship in 2009, 2011, and 2019. But don't forget, FIRST is about way more than just your accomplishments. We also learn valuable lessons like real-world applications for STEM and how to work as a team.
Thank you. Our another question is, how many coins do you have to have? You can lift up as many coins as you would like. You just need to lift it up the said 25 centimeters. Another question we got is, how long has the Rebels been a team? Chloe, could you answer this one?
Sure. The Rebels have been a team since 2009, so we've been a team for about 11 years.
All right, thank you. Another question is, can we put our container in water to lift it? Layla, could you take this one away?
So Layla's having some technical difficulties at the moment, but you can put your mechanism inside of water. Just make sure that it starts within the rules, stated in the rulebook in the description below.
Thank you. Another question is, what can you learn in FIRST? Jessica, could you answer this one?
Yeah, I can. So first, the goal of FIRST is basically to get kids from grade 1 to high school engaged in robotics and other STEM activities. So FIRST is more than robots, is what they like to say. So while there's obviously the fun robotics component where you get to design, build, and also program your robot, there's also the business aspect to it where for us, it's basically we have to find sponsors as well as market our team to get more members. There's also a presentation element to it where FLL, FRC, all these teams have to usually present and explain their design process when they're making the robot and also like how the different parts on the robot work. So we always do that when we have to do competition. I believe that's the general gist of it, but you can find out more if you go to FIRST website. It has information about each of the different categories of teams and can probably be more informative than me.
Well, thank you, Jessica. Another question we got is, what does FIRST stand for? Michael, could you take this one away? Sorry, Michael's having a couple issues with the mute button right now. So, Madeline, could I ask you to answer that one?
Yeah. So FIRST stands for Inspiration and Recognition of Science and Technology, and it's a STEM program, as Jessica stated before, for kids and mentors or really anyone around the world.
Thank you, Madeline. Another question we got is, can parents help you with this? Zoe, could you take this one away?
For sure. So, of course, your parents can help. It's always a great idea to ask for help if you're stuck, but you always have to remember that this is a challenge for you and not your parents. So, always make sure that you are doing most of the work and you're just asking for a little bit of help.
All right, thank you. Our next question is, what parts are there other than the robot? Well, in FIRST, there are 3 parts. We have the core values, which is how well your team works together, the project, which you solve, and a real-world problem, and the robot itself. In FRC, FIRST Robotics Competition, the main focus is the robot, but there are other awards, including the Chairman's Award, which is an overall impact your team has, and there is another business aspect to it, which is getting sponsors for the team and marketing the team to get new members to join. Another question we got is orange juice a liquid or a fluid? Michael, could you take this one away?
Yes, I can. So a fluid is basically anything that's a liquid or a gas, as stated in the live stream that you heard previously. And since we know that orange juice is a liquid, as we can pour orange juice in a cup and it will take the shape of the cup, we can confidently say that orange juice is, yes, a fluid.
All right. Well, thank you. Those were all the questions that we had received tonight, so that concludes our Q&A section. So now could I ask Zoe to wrap up the live stream? Sorry, Zoe, you're still muted.
This is the end of our Elevation Challenge live stream. We hope you enjoyed it and stay tuned for our next one by checking out our social media and subscribing to our newsletter. Please fill in our other Google form to give us feedback and take a look at the printable copies of the rules, which are both in the description below. Just remember that we have 6 awesome prizes up for grabs, including a microbit, some Lego sets, and some cool Rebels merch. We're so excited to see the designs you guys come up with. Have fun. Bye.
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 Grabs, including a microbit, some Lego sets, and some cool Rebels merch. We're so